So now we're going to solve by factoring a different, notice this looks different than the one we did before. The first number is not a 1, and so we spent the whole day on how to factor when a is not 1. So the first step, in order to factor, you need to move everything to one side. So I'm going to move the x over, that makes it a negative x. I'm going to move the 4 over, that makes it a negative 4. And if you want to write that down, minus x, minus 4, you can. I usually just think of it, if you move it to the other side, you change the signs. So now I get 3x squared minus x minus 4 equals 0. Now anytime there's a number, we call this the leading coefficient. Anytime there's a number out there, we should try to factor it out. So I think about 3. Do they all have a factor of 3? 3 does not go into 1. 3 does not go into 4. So there is no GCF. From there, you take this number times this number, you put that on top, and then we covered this last week. So 3 times negative 4 is negative 12. You take this number, which happens to be negative 1, because that's like a 1 out front. And we're trying to find two numbers that multiply to negative 12, but add so what multiplies to negative 12 but adds to negative 1 is negative 4 and positive 3. Negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. So I can write my factors as x minus 4, x plus 3. However, this has a number out front. And so we learned last week, anytime there's a leading coefficient, you should then divide both of these by that number. This is called the slide and divide rule. It's a trick in math. Not everyone's a big fan of tricks, but it does work. If there's a GCF, it will not work and it'll give you the wrong answer. But since we're using a trick, I highly encourage you to always check your work. And so 4/3 does not reduce. So then I would slide the 3 to the front, and you get 3x minus 4. Three divided by 3 is 1. So there's nothing to slide because that reduces to 1. And so this is, if they said, what is this factored, you would just write this down. But they didn't say factor it, they said solve by factoring. So we need to finish and say equals 0, equals 0. And then by the zero product property, if this times this is 0, then either this is 0, this whole thing, or this is 0. So I'd say 3x minus 4 equals 0, or x plus 1 is 0. Now this one's pretty easy. That's x equals negative 1. Because negative 1 plus 1 is 0. This one's a little more tricky. 3 times what minus 4 is 0. So I've been doing these a long time. And so the way I like to think of this, if you're trying to solve for x, so you're going to add 4 to both sides, and then divide by 3. So I know the answer without even doing any work is x equals 4/3. Because you move this over, divide by that. But I'll show you how I got that so fast. I do this in my head. to solve for x, two-step equation for lines. You add 4 to both sides. You get 3x. 0 plus 4 is 4. And then you divide both sides by 3. And that's how you get x is 4/3. Okay, so my two solutions is that one and this one. So now what I want you guys to try to do, I want you to try number 4 from your practice. So go ahead and try that. So go ahead and hit pause, and we'll go over it here in a couple minutes. So we're trying to solve this by factoring. First thing you're going to want to do is move this to the middle here. And so you'd have 3x squared. And when you move something to the other side, it changes signs. Now, it might be tempting to go, okay, 3 times 45, and put that on top of the x, and then put the negative 24 on bottom. It would be better to take out the GCF. And so when I look at these three numbers here, when I look at 3, negative 24, and 45, I notice they're all divisible by 3, so I'm going to take a 3 out. This is called factoring using the greatest common factor. So if I take a 3 out of 3x squared by division, that would just be x squared, because the 3 times x squared is 3x squared. If I divided 3 out of negative 24, that'd be negative 8, because 3 times negative 8 is negative 24. And if I take 15 divided out of 45, that's 15. So by taking out that GCF, I have made this problem way easier. The 3, this all it does is cause a stretch, but it does not change the solutions. So I could just ignore the 3, because the 3 is not going to change our solutions. So ignore the 3. But I'm going to go and factor this. So I need two numbers that multiply to 15, add to negative 8. You could do 15 times 1, which is also 15. Add to negative 8. And so what multiplies to 15 but adds to negative? So in order to multiply to 15, positive 15, and add to a negative, these must both be negative. Because negative times negative is positive, negative plus negative is negative. So the combination would be negative 3 and negative 5. Or negative 5, negative 3, same thing. So from there, I bring down my 3. And I do x minus 3, x minus 5. And it's factored. Okay, this is the factored form. But they want us to solve. The 3 does not change the solution. It just stretches the vertex down a little bit. But here, what number, I set both of these equal to 0. So what number minus 3 is 0? Well, that's easy, 3. And then, what number minus 5 is 0? That's easy, that's 5. So I found that this quadratic has two solutions. Those solutions are 3, and the other solution is 5.